Hi, everybody. Okay, I have some help from my friend who's going to be the hands, and then I'm going to talk us through this model to show you a brief overview of how to use the CRISPR-Cas9 model. So here I have the Cas9 enzyme that I already printed out and put together. This one is laminated, so I can use it over and over again. We see the two tabs taped in. One tape is taped horizontally and one is taped in vertically. You want to put the tape on the shorter ends of each of the tabs so that you can slide your guide RNA and your target DNA underneath those tabs. So let's start with the guide RNA, which we have right here. Notice that it is a hairpin curve in it. That's part of how it binds to the Cas9 enzyme. So it slides in here under these two tabs. This is the guide RNA. Once the guide RNA is bound to the Cas9 enzyme, it'll start searching for the target DNA. Here's the target DNA. It will slide here under the guide RNA. You will slide it under here until the red highlighted regions of the guide RNA and the target DNA line up like so. Okay. Notice the guide RNA is covering the top strand of the DNA, and this red region on the guide RNA is complementary to the red region of this strand of DNA. The first three nucleotides here on the 5' end of the guide RNA are CCC. And here we see on the target DNA strand, it is GGG. Okay, remember that that nucleic acids are anti-parallel, right, when they're complementary to each other. So the 5' end of the guide RNA is here, and it's also the 3' end of the target DNA. Once the CRISPR-Cas9 has found the complementary region of the target DNA to the guide DNA, then it's going to cleave. And you're going to cleave your target DNA at the dotted line. So I'm going to cleave that right here. So now my target DNA has been cleaved. And once the Cas9 enzyme has cut the DNA, then we're going to take advantage of the repair mechanisms that are inside the cell. Remember, there's two different repair mechanisms we're going to talk about. The first one is NHEJ, where the enzymes come in, and they're not using any kind of template or a homologous chromosome. They're just going to insert random nucleotides in this area in order to repair the break. So you're going to take the green section labeled random nucleotides, and it's labeled random because there's no template that's being used here to indicate which nucleotides are going to repair the break. And that would be inserted there on the break. So you can tape it together again. And now there's a new sequence where you put that break. Okay. Now let's do this again with a different guide RNA and a different target sequence. So again, we're going to start with Cas9. Let's get set up here. This time we're using the guide RNA that's labeled RNA2. I'm just going to slide that under the tabs to show how the guide RNA is bound to the Cas9 enzyme. It's a different sequence this time, and we're going to have target DNA sequence 2. I'm going to slide that under our guide RNA again. There's target sequence 2. Get that under the tab, and then we have the guide RNA over it until we have the red sections of our target DNA and our guide RNA lined up. And where they're lined up is where they're going to be complementary. Okay, this time the first 3 bases on the guide RNA are GGG, and you see the complementary sequence on the DNA is CCC. And again, just to emphasize, because it's anti-parallel, this is the 3' end. Once the CRISPR-Cas9 system has found a complementary sequence to the guide RNA, it's going to cleave that target DNA. Again, we're going to cut on the dotted line. Okay, so now we have cleaved our target DNA. This time we're going to demonstrate a different repair process. This is HDR. So in HDR, a template is used to repair the break in the DNA. You know, in nature, it would look like a homologous chromosome. So here now you're going to take the piece labeled donor for donor DNA. And notice the donor DNA is complementary to the target DNA in those red regions. So you're going to take those regions, you're going to line them up. There's overlap between the donor DNA and the original target DNA sequence. And then you're going to tape it together here and here. And now we've inserted 4 base pairs where we have cleaved the target DNA. Okay, I hope this is helpful.